Good day guys, thanks for joining. Today we are going to look at how to model bridging, purlin and base plate. Base plate, there is a macro which will investigate how to put the grout, how to put the base plate and how to put bolts, different type of bolts, chemset bolts, hook bolts, J bolts, etc. And also we'll be looking at how to model the purlins, and we'll have a look at the purlin catalog from Lysort. Almost all Australian purlin catalogs are very similar, and we will also see how purlins are nominated. It is important that you understand about bridging because there are a lot of mistakes which can happen by not knowing bridging thoroughly. It is very important. We'll be dealing with the simple model. I'll give you this model, the stick model I'll give you. We'll add base plates, purlins, bridging, and what I would like you to do is add a fascia purlin here. Now for that you might have to come up with a top plate here and put a cranked angle. Now that I leave to you as an exercise. First thing is to lay out the purlin members. The spacing of the purlin members nominated as 800 here. What we have to do is we have to space this out correctly. Considering that there is going to be a fascia purlin, let's put the fascia out by about 50 mil here, 50 and 50 here. That is where we are going to space the fascia, and the first purlin from the fascia has to be maximum 100 millimeters. That is a requirement. The reason being, if you have a sorry, I have to retract. Well, you need to put one purlin close as possible, and normally it is about 100. Can go a little bit more, doesn't matter. That is if the roof sheet is riding on the fascia. The reason being, there's not a lot of support for the roof sheet. People will put their leg here and this roof sheet can go away. So you want one purlin pretty close to the fascia. When you put purlins, you have to make sure the roof sheet is supported everywhere. So the roof sheet need to have support everywhere. This side, see, there is no support, so you need to have a support here as well. So you need to give something there for roof sheet, but in this exercise we are going to ignore that. To start with, I need a view along this grid line, along the girder. So what I'm going to do is I'm taking a view with 2 points, go to new view using 2 points, and I'm going to select 2 points here and then Control P. Okay, I don't know why it came like that, but it did come like that. Okay, I started the 2 points in the wrong view. That's why it came like that. So first I'm going to put a point 50 millimeters away from there. So I'm going to go points parallel to 2 points. So I'm going to put a 50 mil. Okay, and I'm going to click 2 points there. So those are my 2 points that side, 2 points this side, and I'm going to create a construction line through there. So go line, I'm going to lock Y and just extend, and that's my construction line. Go again, press enter to go again, and then lock Y again from here, and I'm going to click on the grid line. So these are my 2 points. The next thing I want is my purlin is going to be 200 millimeters, and that has to be above this beam by 20 mil. So actual purlin size is a little more than 200. So let us look at the purlin profile. Or actually, what I'm going to do is I'm going to put the purlins, then going to draw a line on top of the purlin to get to this intersection point. I will need this intersection points to put the fascia purlin. That's the reason. The purlins are specified as Lysort Z type 2019. So I go to the model, press the shift key and then click on the beam and the properties come up. Okay, you can pick, there are some predefined here. You should be able to get purlin from there. If you don't get purlins, then what you have to do is you go there and pick, type in LYZ, type in LY star, cold rolls will come up. You go in there, Lysort profiles, Z's, and pick up 200 by 19. That should be here, 200 by 19, and go apply. H is here 203. You can see that it's not 200, 203, but it will be specified as 200 purlin. Okay, so I have applied the profile. Now if you look at the drawing, see that 20 mil and see the rotation of the purlin. It is rotated from the vertical, so that is the vertical. And how many degrees? Well, it is rotated by 5 degrees. So what we are going to do is we are going to open a view on top of this beam. There are a couple of ways to do that. I'm going to set the work plane parallel to this beam, and then I'm going to open a view on work plane. That's how I am going to do. There are various ways to do it. Okay, so I go to view, work plane tool, and I'm going to set the UCS to the top of the work plane. So there it is, I set it, and now I'm going to go and open a view on work plane. So this is the work plane. You can see that it is a bit tilted. That's a view we saw before. It's a bit tilted. Okay, now I have to put the space out the purlins evenly. That is the first purlin about 100 millimeters from there, from here also 100 millimeters, and then space out so that the spacing is not more than 800 or less. See, the purlin specifications will tell what should be the spacing. Normally 900 or maybe 1000. It can't go more than that, but it can go a bit less than that. There is no problem. You don't want to come too close because you will buy a lot more purlins. So let me draw a construction line. There are okay, edit construction line. So I'm going to go, this 1000 spacing is not super critical, so it can be taken as a projection or like that, but normally it should be taken parallel to the purlin. So I'm going to go like that. Okay, and where's my construction line? Now I'm going to hide that, and that is my purlin. That's my construction line. Why can't I pick it? Okay, and I'm going to move the handles. I selected the handle by pressing the key and drawing a window over that, and then move, edit, and move. I'm going to select that point and that point, so it extends a little bit. And okay, I have got an intersection point here, so that is sufficient. Okay, if you redraw, so you can go redraw, and if you don't see the construction line, double click in this area, go in there, and then take this construction lines on, because if I switch it off and redraw, you can see the construction lines are gone. Tick it on and modify, and they're back on. Okay, now I have to get a couple of points here, 100 millimeters away from there. So what I'm going to do is edit, points. You can see that you need to know the points pretty good, okay, otherwise you have a problem. Parallel 2 points, I'm going to go 100, apply OK, 100, the other, the other side, I need another this way. Okay, I got these 2 points, I go another construction line. So let me hide this one. So between these 2 points, I'm going to divide it equally. How many purlins we require? 1, 2, 3, 4. So I'm going to put 4 equi-space points between them. Okay, the intersection point normally clicked off. I click that in and then I go points. On line, we need 4 points. So go 4, apply OK, and pick these intersection points. And then we got the points, we better measure it. Should be less than 800. 623 are a bit too less. Can we do with 3? Let's have a look. Points online 3, apply OK, and go from here to here, measure. Yeah, 3 will do, so only 3 purlins required. And let me redraw. So we got all these things, the points have disappeared. So double click, points, modify. Okay, we got the points back. So we switch back to the view. We open parallel to the top of the beam. I double click, I want to see the points, so I go points, modify. Okay, we got that. And now, which are the points we were looking for? It doesn't matter which points we were looking for, we'll just pick one of these points. Well, it does matter. Row P. Okay, we were looking for, we don't want this point, delete it. We don't want that point, delete it. We don't want any of these other points. I'll delete all of that. Okay. So I look at the beam properties. I want to pick up the purlins. I can pick up purlin from here, purlin, and it comes up with Lysol 219, which happen to be ours. If you don't get that, then what you have to do is go in here and then type in here filter, and you will get that. Apply OK. And the other thing which you have to note here is this is set at a depth of 10 mm, but this is at the front. So even though it says depth, this will come 10 millimeters above the face where we are going to put it. So where are we going to put it? We open a view at the top of the beam, but this is where we are going to put that. Okay, so we go then one. Let me pick up the purlins, beam properties. Purlin, we want 20, so set it at 20. Hit enter, and then I am going to draw a purlin. I put the mouse over there and lock Y coordinate. Locked Y, then I am going to click on that end all the way there. Okay, there's a purlin, but it didn't lock somehow, so I'm going to move it. Okay, I have moved that purlin to that position. That looks good. Okay, that looks good. It is perpendicular to the parallel to the top of the purlin, and it is 20 millimeters above. Now I just have to copy this across, so go copy spatial. I'm going to use copy spatial linear clear and pick 2 points. I'm picking 2 points because this view is parallel to the purlin, parallel to the rafter, and we want to copy parallel to the rafter. So pick 779.9, so not copy. So copy spatial, pick 2 points, and that's the value I get. How many copies I need? I need 3 copies that way. Copy, and then I want 1 purlin on the other side, so I go -1 and then put 1 here and then copy. So I got all my purlins here. Okay, may not be quite right. Okay, I will move this one a bit in by want the tail to come in, so by about 50 mil, -50, copy. Okay, delete that, and then this one I'll move by 50 mm. That's the other way. You just make sure it's correct. Okay, delete that one. That looks pretty much good. Next thing we want to do is apply bridging. Now there's a bit involved in bridging. I'll first show the macro, then rest of the class we will deal with how to deal with bridging. Okay, the macro is 80, so you type in 80 and press enter, and the bridging macro will come up. So I am pressing shift key, double click, and the properties come up. So this is the picture of that. What is bridging? It's just a connection between purlins so that the purlins doesn't roll or sag. Purlins are slender members and long members, and slender section is very, very thin, like 1.2, 1.9, maximum 2.3, I think. And it will roll by itself, it will roll. So they have to be restrained from rolling and sagging as well. So in a horizontal situation, the bridging helps to prevent rolling, and if the purlins are vertical, it also prevents sagging. And the bridging normally will have to be anchored to a structure member, but in this case need not, because it's only preventing rolling. And if you look at the parts, it has got some, see, none of these values are filled in, and the material is put as G450. Well, G450 means 450 micron galvanizing thickness on that. That is a plating thickness. We actually want only 350 most of the time, so we put 3. I don't know whether it will take it because it has to be there on the catalog. So anyway, I'll put 350. Alright, it says that it is not in the material catalog, so we're not going to correct that. We're going to leave it at 450. And you look at the parameters, it says 2 rows of bridging. We'll put 1 row of bridging here now. And if you look here, state of use, this is Australian environment, so it has got some spatial things, especially Victoria has got some spatial. So VT is Victoria, so we'll pick that Victoria up. And it is only spatial for 150 purlins. For 200, 230, any other size of purlin, it's the same. So only 450. Here we are going to deal with 200, but anyway, I just picked up Victoria. Okay, purlin type simply supported, purlin location, all that generally default. Selected rafters, bridging spacing, we are going to use the rafters to space it out. Okay, now let's do that. So select the bridging macro. It says pick object, so we have to pick a rafter, and then we have to pick another rafter, and then we pick the purlins from start to finish. 1, 2, 3, 4, 5, and then to end, middle button. So that's a bridging. Okay, the bridging is only a representation. This is not how the bridging looks like. We'll deal with that a bit later, okay? So this is only a representation. What it does is it draws a member and then put two bolts on the purlin. So you need something to bolt on, and that is how the bridging macro works. Now what all these means, we will deal with that next. Okay, now I have downloaded the Lysort catalog. Stramit is very similar, so you can look at any of the purlin systems in Australia, bridging systems. They are all very similar. There are 2 or 3 companies. So how that works is, see, this is the purlin. We have a Z purlin, but this is showing as C purlin. That's okay. And then on the first purlin, there are 2 bolts here. And there is a central member which is a C channel, which is connected to that end bit, and then on the other end there is another connection, and that is a clamp end which ends at a purlin. Then on the other side of the purlin we have a locator end. So we have a bolted end, a clamp end, a locator end, and then again a clamp end, a locator end, and then a clamp end and a locator end. Well, this could be a turnbuckle type of a item, but this will be a clamp here. Or if you look at this one, it could be a locator, the other end could be a bolt. If it's a bolt, it has to be bolt both sides. We will look at some YouTube videos now. Here I am going to play a YouTube video on Stramit bridging.
Way called up the slope. Some areas of Australia prefer to install up the slope, while other areas prefer to install it down the slope. The direction of installation will need to be established at the design stage before procurement, as the starting and finishing components are different. In part 3 of this video series, I'll demonstrate the down the slope method, but for now, let's look at up the slope method. With up the slope, we begin at the bottom of the purlin run. This is our fascia purlin, and here's the first intermediate purlin. I'm going to start by installing the fascia bridging. We're going up the slope, and the simple rule is that the locator prongs are always pointing in the direction that we're installing. So this fascia bridging has a locator on one end. Now you'll notice that on this roof we're using Z purlins, and the top flange is pointing up the slope to maximize their performance. I'll maneuver the bridging in between the 2 purlins and rest it on the bottom flange. To install, I push the 2 locator prongs through the holes in the purlin. Take note as the locator clicks into place to indicate that you have captured the purlin. This click is an indicator to let you know that the connection is secure. If you don't hear a click, you may need to remove the bridging and try again. You'll notice that now I can push the purlin, pull it towards me, twist it, or more correctly take any twist out of the purlin. Next, I'll pick up the bolted end of the bridging and pop a couple of fascia bolts through the fascia to hold the bridging in place. You'll need a spanner or a socket wrench to fully tighten up the nuts. In the middle of this fascia bridging, we have the slotted channel that I can adjust. However, I'll leave it for the time being and adjust it last. For now, I'll grab a piece of intermediate bridging and move on to the next bay. Next, I have a piece of intermediate bridging. Again, remember that the locator prongs always point in the direction of installation. So in this roof, it's up the slope. Now, just like we did before, I'll reach out with the bridging and slot the locator through the holes in the next purlin. You'll hear it click into place. The purlin is now captured. Next, I'll swing the bridging around, and if we look at the purlin on this side, you'll notice 2 locator prongs from the preceding bridging. The lock on the intermediate bridge will go over these 2 prongs, and you should hear it click in place. The bridging is now secured. You can see how fast and easy it is to use our bridging system. I can now continue moving from bay to bay, installing the intermediate bridging until I get to the ridge. And that's what we'll look at next. The ridge bridging is the last piece to go in, and it looks like this. You can see we have two ridge purlins here, and down there we've run a row of intermediate bridging starting from the fascia, and we've done the same thing on the other side. Now it doesn't matter if you've done one side of the roof left-handed and the other side right-handed, because our piece of ridge bridging will simply rotate around to match up. You'll see at the ridge that we have two locators on both sides, and therefore the ridge bridging has locks on both ends. We simply take the bridging and snap it into place, there and there. The bridging is now secured and locked in place. I'm going to adjust the ridge bridging, and at this time it's very useful to have someone on the ground helping you out. We either open the turnbuckles to push the ridge purlins apart, or close the turnbuckle to pull them closer together. You can use a tape measure to adjust the purlins, but it's actually a lot easier to have someone at ground level eyeballing the purlins and directing you to bring the purlins closer together or further apart until they're both parallel. Once you've adjusted the ridge, we now return back to where we started at the fascia. I'm now back at the fascia bridging that I installed earlier in the beginning. All the purlins on the roof are pulled up nice and tight after we've adjusted the turnbuckle at the ridge bridging. The purlins should all be nice and straight now. Now I can adjust the slotted channel and fascia bracket. Firstly, I can pull or push the bracket in and out, and secondly, twist the bracket to get the fascia straight. When I'm happy, I can tighten all the bolts to lock it securely into place. I then go across to the other side of the building and repeat the adjustment on the other fascia. That's it. That row of bridging is now installed, and I can move on to the next. Please refer to part 2 of this video series. This time we start at the ridge, and I'll fit a ridge bridging piece which looks like this. Notice that it has a locator at each end. Remember, the locators point in the direction in which we install the bridging, so the locators are pointing down the slope or away from the ridge. I'll adjust the turnbuckle roughly to the required length. If you prefer to install the bridging from the same side, ensure that you have one of the locators rotated around so that legs face in the opposite direction. Next, I can push the locator prongs through the holes in the purlin on one side. The click is an indicator that it has connected securely. If you don't hear the click, you may need to remove it and try again. You can see the ridge purlins are quite flexible, and sometimes you can push and pull them away to allow the locator prongs to enter the holes correctly. However, you may prefer to unbolt the locator from the turnbuckle, and this sometimes makes it easier to get the two locators in position. Either way, ensure that the two locators are properly seated, and then tighten the bolts connecting the turnbuckle to the locators. Next, you'll need to adjust the turnbuckle so that the two ridge purlins are parallel and in line. We either open the turnbuckle to push the ridge purlins apart, or close the turnbuckle.
Okay, that was the video on YouTube about Stramit purlin installation. We are getting back to our model now. Click in this button so that you can select parts inside a component. That's what we want to do, and I have selected this bridging, and let's read the name of this. This name is important. You cannot change this name because then you will get the bridging wrong. So if you look at the first two letters, it says S2, which is a hook lock system. And then the next thing you have to look at is the next letter C here and B here. Okay, we went from this side to this side. It doesn't matter which way side you go. This name will be put in some arbitrary way. So one end is a bolting end. That's what you've seen in the video. The fascia is bolted. So that is that end. And the other end, in the video it says it's a locator, but here we are coming down, so it is a clamp end. So that's a clamp end. So this will be a clamp end. And that is denoted by the C. Then 20 is the depth of the purlin, which is a 200 purlin. And the P represents the type of the member, whether it's a slaughter member or it's just a straight channel without any slots cut to length. So that is what it denotes. Then if you select the next one, you can see it will be both ends is either C or L. So the locator is this end, clamp is this end. Now if we go to the next one, again same thing. Locator is this end, clamp is this end. Now if you select the last one, you can see the last one, this one will be a bolted. So bolted, locator, 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 bolted. And bolted, clamp on this end, clamp on this end, clamp on this end, and clamp on this end. This is extremely important to understand. The other thing about this is this type of system with a hook lock system with a clamp and a bolted end has to be in one straight line. It cannot have up and down. For the fascia is normally not at the same angle, it will be rotated. So you need to have a different type of a channel, which is a slotted channel. You have to go through the Lysort catalog and understand that. Next, I have to put some cleat connections between the beam and the column. So I select a shear connection 34. I'm going to use the default, but after putting, you check the thickness, the bolt distance, the edge distances, etc. The minimum edge distance required is 35, and the clearance of the beam from the column face should be 20. So you got to check all that. So I'm going to go select that one, select the column first, that's the main member, and the second member is the beam. So that is the connection. Now to check, let me hide what is on the background. Hide, Control P, and check the distance. Measure from here to here. 10 mil, not sufficient. I need 20 mil. 10 mil, problem is the weld itself may be like 6, 7, 8 mil. So I'm going to put here 20 mil. 20 mil and modify. Okay, check again. From here to here, 20 mil. That's good. And the bolt center distance has to be 70. Let me check that. From here to here, 60. 60 no good. I want 70. So I go to bolts. I put 70 and then modify. So let me check now. 70. I can save this as a connection. So let me say shear. I'll put SC1. SC1. Save as. If I go into the model folder, open model folder, go into attributes folder, sort by date, I will see that file here, SC1. You can copy this and take it somewhere else and use that again.